Good afternoon, ladies and gentlemen. We are continuing where we left off with our first-person shooter tutorial. So what we're going to be doing today is we're going to be creating a state machine for our enemy and two states to go with it. Alright, so basically what these states are going to do is have our enemy move towards, basically patrol an area following these paths, or these nodes. And if you get too close to the player, he'll turn around and start chasing after you. Right? And once you get far enough away from the player, you'll go to the nearest node and move on. Alrighty. So let's get started. First thing we're going to do is I'm going to create a new folder in our scripts folder, and we're just going to call it states. And I'm going to create a class called state. And I'm actually going to create 4 classes right off the bat, and we're going to fill them out as we go. Alright, so we're going to create state, create another C# script called state machine, and we're going to create a C# script called move along path. And we're going to create another C# script called move towards player. Alright, and the first thing we're going to fill in is our state class. Alright, so once that opens up, what we're going to do is we're going to get rid of mono behavior here, and it's not going to extend from anything at all. State is going to be its own class. Alright, and we're going to make state generic. And to do that, we're going to use a less than symbol. We're going to type in T, capital T, or whatever, and then a greater than symbol. Alright. Now T can actually be anything you want. Alright, it can be type, it can be tutu, whatever you want. I'm just using T as a really short form for type. Alright, and when we actually create a state, it is going to T is going to be replaced with whatever class that we want the state to belong to. Alright, so in the future, when we're creating states for our enemy, instead of T when we're making the class, it's going to be enemy. Alright, and we want state to be an abstract class. Alright, we don't want anyone to actually extend or to instantiate a state. Only the classes that that extend from it. Alright, so we're going to create 2 variables, and our first one is going to be protected T, and we're going to call it owner object. And the next one is also going to be protected, and it's going to be called state machine T and owner state machine. Alright, so when we fill in our state machine, it's going to be generic just like state is, and for the exact same reasons. We only want it to belong to a certain class. Alright, now we're going to create 4 methods, and the first one is going to be public and abstract, and the void is going to be called check for new state. The next one is also going to be public and abstract and void, and it's going to be called update. Alright, these 2 could be one method, but I like to separate out the logic. It just organizes your code a little bit better. Alright, and the next method we're going to make is going to be public and virtual, and it's going to be called onEnable, and it's going to take 2 parameters. One is going to be T, is going to be called owner, and the next one is going to be a state machine of type T, and we'll just call it new state machine. Alright, and then onEnable, we're just going to set owner object to owner and owner state machine to new state machine. Alright, we keep references of them so that we can do whatever we want within the state, applying to our owner object. Alright, And the last method is going to be public virtual void on disable. All right, and we're not going to do anything by default. We're just going to leave it blank, but we don't want it to be required to be filled in like we do with the update and check for new state, because you may not want it to do anything when you're removing the state from the state machine. All right, and that's pretty much it for the state. It's simple as that. All the functionality comes from the states that extend from it. Next thing we're going to do is we're going to fill in our state machine class. All right, so we're going to open up state machine. And the first thing that we're going to do is we're going to get rid of that. Get rid of it. And we're going to get rid of mono behavior. And we're going to make it generic, just like we did with our state class. All right. So our first variable that we're going to make is going to be of type T. And we're just going to call it owner object. All right. The next thing we're going to do is we're going to make a private state of type T, and we'll just call it current state. And next we're going to make a property for that current state. All right, so public state T and current state with a capital C, just so we know it's the property. We're going to make our get method, and all we're going to do is return current state. And next we're going to make our set method. And we're going to do things a little bit differently here. First thing we're going to do is we're going to check if current state is null. So current state is not equal to null. If it's not equal to null, we're going to call its onDisable method. So current state dot onDisable. All right. Next, we're going to set current state to whatever value is being passed in to our current state property. And we're going to double check that whoever passed a value into current state didn't just pass null in. So if current state is not equal to null, current state dot onEnable, and we're going to pass in our owner object, and we're going to pass in this. And this represents the state machine itself. All right, so if we instantiated a new state machine in our enemy, and we called this on that state machine, it's going to pass in that object. Not the enemy, but the state machine itself. All right, next we're going to create the constructor for our state machine. So public state machine, and we're going to go with state of type T, and we'll just call it default state, and T owner. All right, so when we instantiate a new state machine, we're going to give you the opportunity to give it a default state to go to. You can just pass null if you want to, doesn't really matter, or you can create a brand new state and it'll automatically go right into it. And then we're just going to pass in the owner or object that owns this state machine. All right, so what we're going to do in our constructor is just set our variables to whatever gets passed in. All right, so owner object is equal to owner, and current state with capital C is equal to default state. All right, we're using capital C because we want this stuff to happen. All right, and we're going to create another new method that's public void, and we're going to call it update. And we're going to check and see if the current state is null. All right, so if it's not equal to null, we're going to check for the new state and update. So current state dot check for new state, and then current state dot update. All right, and again, that is it for our state machine. Now we're going to fill in our states and then set up our enemy to actually use the state machine. All right, so let's go back into Unity and let's open up our move along path state. All right, so instead of extending from mono behavior, we're going to extend from state. And we want this state to only belong to our enemy. So since state is a generic class, we're going to pass in enemy where we would have normally passed t. So we're going to extend from state, and in our little angle brackets, we're going to pass in enemy. All right, and now instead of just being t, owner object is going to be an enemy, and state machine is going to be a state machine that only accepts enemy states. All right, so what we're going to do is we're going to create one variable, and then we're going to fill in our methods. So our one variable is going to be called node index. So int node index is equal to 0. All right, next we're going to override our check new state method. So override check for new state, and what we're going to do is we're going to use physics to cast a sphere around the enemy object and check and see if there is a player inside that sphere. And if there is a player inside the sphere, we're going to move to our move towards player state. If there's not, then we're just not going to do anything. All right, so what we're going to do is we're going to create a collider array, and we'll just call it other objects, and we're going to set it to physics dot overlap sphere. And in overlap sphere, we're going to go with owner object dot transform dot position. Let's make the radius of our sphere, say 8 meters. Like, he has a pretty decent distance, but you know, he's still kind of blind. So we'll just go 8.0, and we're going to use a layer mask. So to use a layer mask, we're going to go with 1, 2 less than signs, and layer mask dot name to layer, and the name we're going to pass in is going to be characters. All right. So when we pass in a layer mask, we basically only do this overlap sphere on objects within that layer. All right. So if we go back in the Unity, we're going to see that the wall is on a default layer, the floor is on the floor layer, and our character, wherever it is, first person character, is on the characters layer. All right, so yeah, when we're doing our little sphere cast, it's only going to be checking on objects on our characters layer. So it's going to be cheaper that way, and it's basically going to make sure that only characters show up within our sphere. All right, so we have our array of colliders that came back from our overlap sphere, and now we're going to iterate through them all and check and see if any of them have the FPS character script on them. So for int I is equal to 0, I is less than other object dot length. Let's make it plural just to make more sense. And I plus plus. All right. All I did there was just add an S to the name because there's multiple objects potentially going to be there, so it just makes more sense. You can actually just leave it to whatever you want, or name it to whatever you want. Call it poop. See if I care. All right. So for int, we did the for statement, so now we're going to do an if statement. If other objects at index of I dot get component FPS character is not equal to null. All right, so if this is the first person character, owner state machine dot current state is equal to new enemy, or new move towards player. All right, so we create a brand new move towards player state, which we still need to fill in, and we set it to our current state. And then state machine goes through all this stuff, does the on enable, and now it's going to be in the move towards player script or state, and it's going to start running towards the player instead of along its patrol path. All right. Next, we're going to override the update method. Now, we're going to do an if statement, and in brackets, we're going to go with owner object dot path nodes dot node index dot position minus owner object dot transform dot position dot square magnitude on the outside of the brackets is less than 1. All right. So what we're doing here is we're basically grabbing the difference between its current path node position and the transforms position, and we're getting the square magnitude of the distance between there. All right, the magnitude of the distance is a little bit more expensive to calculate, and it's pretty easy to just kind of take the square magnitude into account, and it's a lot cheaper to do, so that's why we're doing it this way. And we're basically just checking to see if it's less than a meter away from the path node. And if it is, we're just gonna move on to the next path node. Alright, so we're gonna increase our node index. We're gonna check if node index is greater than or equal to our patrol area node length. So owner object dot path nodes dot length or dot count node index plus plus, or no, node index equals 0. Sorry about that. All right, so if it's greater than the maximum amount of path nodes, we're just going to set it to 0. All right, and owner object dot target is equal to owner object dot path nodes at path node, or at node index. All right, so we're just going to set the target so that the navmesh pathfinding can find its way to its path node that it's currently targeting. All right. Next, we're going to override the onEnable method. All right, so automatically calls base.onEnable, which fills in the owner object and state machine. And after that, basically what we want to do is find the closest path node to our character. So let's say your first path node is on one side of the map and your enemy is on the other. It doesn't make sense to make it move towards the first path node and then move towards its path. It would make a lot more sense to move to the closest path node to the character and then continue on the path from there. So what we're going to do is we're just going to create a float value called closest distance and give it the maximum value that a float can hold. So float.max value. All right, now we're going to iterate through every single path node that the enemy has, and we're basically just going to check and see if the distance is smaller than closest distance. And if it is, we're going to set closest distance to that value, and then that index that we were at is going to be the path node that we're going to move towards. All right, so we're going to iterate through them using a for statement. Int I is equal to 0, I is less than owner object, or owner dot path nodes dot count I plus plus. All right, float current distance is equal to, in brackets, owner.transform.position minus owner.pathNodes at index I dot position dot square magnitude. So just like before, square magnitude is cheaper to calculate, so that's what we're going to use. I'm going to do an if statement. If current distance is less than our closest distance, closest distance is equal to current distance. All right, we want to set that value, and we're going to go with node index is equal to I. All right, so currently that is our closest node, so we're going to set our node index to that, and we're going to iterate until we find the very closest one. And then owner object dot target is equal to owner.pathNodes at node index. All right, and that's it for the move along path state. So next thing we're going to do is get into our move towards player state. So our move towards player state is actually a lot shorter than the one we just did, so that's nice. So instead of mono behavior, just like before, we're going to extend from state, and we're going to pass an enemy as our type. Get that out of there. Now we're going to override our check for new state method, and if, in brackets, just like before, we're going to do our square magnitude check. So owner object dot transform dot position minus owner object dot target dot position, and then square magnitude on the outside of those brackets. Let's say that's greater than 100. All right, so basically what we're going to be doing here is checking to see if the distance between the owner object and the player is greater than 10 meters. All right. So square magnitude is the magnitude times the magnitude. So 10 times 10 is equal to 100. So that's basically how we're basically making up for the square magnitude. It's cheaper to do, but you basically need to multiply the distance you want to check by itself when you're comparing. All right. So if the distance is greater than 10 meters, owner state machine dot current state is equal to new move along path. All right, and then we'll just revert back to our moving along path state. All right, the next method that we're going to override is our update. We don't actually need to do anything in update, but because state declares it as an abstract method, we have to create some sort of version of it. So even if it's empty, we're still making the compiler happy. And lastly, we're going to override our onEnable method. All right, so it calls base.onEnable like we want. And what we're going to do is as soon as the state comes into play, we're going to set the target of our enemy to the current player. So owner.target is equal to object.find object of type, and we're going to pass in FPS character, and we're going to grab the transform. All right, there should only be one FPS character in the scene, which will be the player. So we're just going to check in, or we're going to find that character, and we're going to pass the transform into the target. So the enemy will now start moving towards the player. All right, and that's it for that class. So now we can start getting our enemy set up. So we'll go back in the Unity, and we're going to grab or open up our enemy script. All right, so now that we have the enemy script open, we're going to create two new variables. One is going to be a list of transforms, and that's going to be holding the path that the enemy is going to patrol. And the second is going to be our state machine that uses enemy states. All right, so the first one we're going to make is our list, and if you're going to use a generic list, it's in the system.collections.generic library. So to get access to that, we're going to go up to our top and go using system.collections.generic. All right, and now we can create a public list, and we can pass transform into that list, and it'll be basically like an array of transforms, except you can increase and decrease the size of it really easily. And we'll just call it path nodes, and we'll just set it to a new list. All right, next we're going to create a private state machine that only takes enemy states, and we'll just call it state machine. All right, and to start, we're going to set our state machine to equal a new state machine, and our default state, we'll just set it to new move along path, and then we'll pass this. All right, so this is going to be the owner, and we're passing the enemy itself into the state machine. and then we're giving it a default state, which is just going to move along the path. Alright, and the only other modification we need to make is in our update method, and that's basically just telling the state machine to update. So state machine dot update, and we should be good to go. So if we go back into Unity, see we have some errors here, and it's basically just giving us some type errors. So let's see what's going on. It says that the state machine is requiring a state that is a test type and not T. So this might not have happened to you, but I have a fair amount of classes that start with T. So it just, IntelliSense worked against me and filled in test instead of T. So if I get rid of that, it should be good to go. And it is. Alright. Stupid little issues like that. Alright, so now we should start setting up our enemy character within the scene. So this is my test character. We'll get rid of him. And we'll bring our enemy back. Alright, so I just moved my enemy up to this little ramp here. And you'll see that it now takes path nodes on your enemy script. Alright, so you can pretty much set these path nodes to whatever you want. They can be boxes or trees or whatever. And he will move towards those path nodes basically. Alright, so I just set up these spheres up on the bridge here, and all I did was just create a sphere and get rid of the sphere collider on it so that he can pass right through them. Alright, so we're going to select our enemy. We're going to set up our path nodes. You can do whatever you want for those. I set up some path nodes beforehand, so I'm just going to use those. And now when we hit play, he should move along the path. Alright, so if we run up to the bridge, see he's moving towards the path, or moving along the path, and he should move towards the last one. If we get close, he's going to start chasing after us. If we run away, he's going to be like, oh, fine then, don't play. And then, you know, you can start bugging him. You're going to jump off a bridge, and he'll start running away. And yeah, so now we have an enemy that has some really basic AI, where he's actually going to start reacting based on what's going on in the level. Alright, and I challenge you guys to start extending these states further. Create a state where the enemy will start shooting at the player, or if the player gets, or if the enemy gets to a certain amount of health, it'll start running away from the player. Stuff like that. AI basically runs off of these types of state machines. The one that we just created now is very basic. You can set up state machines so they have kind of like a stack of states where you can push and pop them onto the stack, and instead of starting from scratch, it'll just pick up where it left off. Yeah, basically this is the very basics of AI. You can actually start getting your characters to start acting somewhat realistically now. Alright, so that is all for now, ladies and gentlemen. So I will see you guys next time.